I'm Jaime. I'm from Fitchburg State, majoring in electronics engineering technology.
Hi, I'm Mike. I'm from Fitchburg State as well, and I'm also majoring in electronics engineering.
And today we're going to talk about a self-watering plant that we made and designed.
So for the project description, generally the winter season starts from around November to February every year in the New England area. It tends to last about 3.5 months on average, and the freezing temperature kind of forces us to stay indoors during the winter season, especially with the COVID-19 pandemic going on. So in order to keep the social distance, we tend to stay inside.
As we know, the indoor humidity and the oxygen density is low after we turn on the electric heater in the winter. Therefore, many plants need to be planted inside the house. These plants generate fresh air and keep the humidity density higher for the people who work at home. Moreover, we need to plant the indoor plants and monitor the soil status frequently, such as whether the soil is dry or wet. In addition, there is a need of automated watering system for the indoor plants. It is more effective on the indoor life during the winter season.
So here's the flowchart for the self-watering plant. It starts at a microcontroller system, which is the Arduino we used. That then goes and reads the water level and soil moisture of the plant. From reading the water level and soil moisture, it will display the percentages on the LCD display. So at the same time that it reads the water level and soil moisture, it asks basically two questions. Does the soil have sufficient moisture, and is the water level sufficient? So it can go to either one, and it will read the level. If it is not sufficient, it will turn, for example, for the soil moisture, it'll turn the water pump and the LED indicator on to let you know that it's pumping water. And for the water level sufficient, it'll turn on the LED indicator to let the user know that they need to fill it.
And for the code, this is a small snippet of it. You can see I listed several variables such as the pump, the LEDs, the LCD screen, and so on.
So here's the 3D render of the self-watering plant.
And this is our project demonstration. And today we're going to go over our self-watering plant project we've been working on. So you can see these electronics. We got this microcontroller, this Arduino, which program and powers the whole thing. We got an LCD display, which reads us values. We got this potentiometer to adjust the display. We got two LEDs, one for the water in the soil and one for the pump. And this is to measure the water, the amount of water we have. And this is to measure the moisture of the soil.
So based off of my partner's requirements for his electronics, we designed a 3D printed housing to be able to contain all of the electronics. So we have this compartment here, which is made for the electronics to be housed. We have a cutout in the front for the LCD display, the potentiometer, and the LEDs. In the back here, we have the housing for where we keep the water that has the pump and the tubing inside to deliver the water to the plant. And then in this housing here, we have the space for the plant to stay itself, so that we can keep everything separate but all in one system.
And if we look here at the code for the Arduino, you can see what we have made. You can see it reads the analog values for the water level and such. And just skim through this. Okay.
Now,
So we'll do a demo now to show you how this works.
So you can see the LCD is reading the percentage of the soil moisture, and it's showing the percentage of water level. And as you can see up on the top with the sponge, once we take the sponge off, the pump turns on and it goes to 0. And if we put the sponge back on, the pump turns off and the percentage rises. And for the water level sensor, if we wet it, you can see it turns on, it goes up. And if we take it off, you can see this turns on and this goes to 0. And I can adjust this for you. Summary and future work. This is our first prototype and we have approached our goal. However, each house space is different and they have different oxygen needs. At the same time, we would like to monitor the environment status, such as humidity in the air, temperature, and ultraviolet rays. In the future, we would like to implement more sensors and sync it to our smartphone to get more data.
Thank you.
Thank you.